We're not going to do all of them, don't worry. Everyone got a white and a blue sheet that just came in? All right, this should look very familiar. And where's Sophie? Vocab associated with geometry to start and the symbols that go with them. So you're going to fill out this chart on the front with me. Here we go. First word that you see in your table is segment. A series of points with a definite beginning and a definite end. So again, perhaps you did this in your own 516 geometry unit. But let's say we had a segment AB. One single line on the top. No arrows at all on either end. All right? Segment with closed ends. As an example, you can draw a picture from A to B. Closed ends. It has a definite start and finish. Similarly, we have lines in geometry. Let's say, for example, we have line AB. Difference? The ends keep going. You signify that with your arrows. So similarly, we'll draw a line. Don't forget the arrows on those ends. And all we're saying is that line just so happens to contain A and B. Should be familiar. You guys did a whole geometry unit in 516. All right. Marquina, what is a ray symbolized as? A series of points that begins at an endpoint and extends infinitely far in only one direction. So how would I draw ray AB?
One dot, and then the arrow.
One way, right? So that's your symbol. Let's say here's A. Draw your arrow through B. Okay? We have segments, we have lines, we have rays, and we have angles. So angles are two rays that share an endpoint. So symbol for this, we'll talk about naming angles. Let's say we have angle ABC. Looking there, you should know that again, your symbol for angle. So let's say we had an angle, ABC, two rays connected and sharing the same endpoint. So angle ABC. Angle ABC. Swabi, do you remember what we called point B?
The vertex.
The vertex. So there are three ways to name this angle. I can call it angle ABC, CBA, and I could just call it plain old angle B. So all three ways are in place. Any way you want to name that angle, be familiar with all three. All right, after angles comes this idea of collinearity. Collinearity. The idea that all points lie on the same line. It's a concept. So there's really no diagram or symbol for it of any sorts. But there is a nice picture you could draw. Points are collinear if they all are on the same line. So let's put A on the line, let's put B, and let's put C. All 3 points lie on the same line. You would simply say that points A, B, and C are collinear. Okay? So A, B, and C here, A, B, and C are collinear. Is D, some random point off the line, collinear with A, B, and C? No. Okay? All vocab.
Attention please. The last AP pre-administration session is happening right now in the cafeteria. Once again, the last pre-admission.
All right, the next word of betweenness is kind of odd, but it comes up a lot in this gap topic, stuff.
The last AP pre-administration session is taking place right now in the cafeteria. You must attend this last session in order to take the AP exams in the next 2 weeks. Thank you.
So betweenness simply means that some point may be between two others. A more formal definition, the notion that a point is intermediate to two other points. It's in between, really is what it sounds like, right? So if you have some line ABC, you would simply say that B is between A and C. Bless you. Little catch to this, if betweenness is to exist, then the points must all be collinear. So you use that old definition from there, okay? So not only can they be between, they have to be collinear, okay? All right, let's go to bisect. The idea that a point, segment, ray, or line can divide a segment into two congruent segments. So no symbol again really for this. We're going to go right to a diagram. Please draw a segment AB. And please draw a second segment coming through, and let's call that CD. So if something is to bisect, it must divide the segment into two congruent segments. So if CD is to bisect AB, I'm going to make two little marks. Familiar with those single dashes? Right, to show that they're equal. So you would then say CD bisects AB. And lastly, the idea of midpoint. The bisection point of a segment that divides the segment equally into two parts. The bisection point. So that's specifying you've bisected the segment, but there is some point, let's call it C, in the middle that allows the two segments to equal. So C would be the midpoint. Okay? Hi, Mr. Monk. So everyone has the purple sheets on their desks? I'll go around. Okay, and then who signs their purple sheets? You do that. Okay. All right. So that's all diagrams, notations for page 1. John, we have acute angles first. Can you tell me what acute angles are?
Below 90 degrees.
Very good. So angles that measure less than 90. So a little picture to go with it. Let's say we had a 40-degree angle. Okay? Acute. Next. Right angles. Yes? Measure
90 degrees.
90 degrees. Please make sure as well, because we're not going to be able to assume right angles unless they're labeled. We're going to talk about that in a moment. Don't assume it to be right unless it's labeled. So only if there is that marking do you assume it's right. Obtuse angles. Greater than
Oh, less.
90, but less than 180. Again, hopefully got this in your math courses this year. Little repeat on this note sheet. Obtuse angles, let's say this was 110 degrees. And then lastly, straight angles. Who remembers what a straight angle is? Yeah,
180.
good. Okay, so those hopefully review of sorts. But you're going to need them for the practice problems you do within the geometry packet, and make sure you know what they're called. Alright, down the bottom is nothing that you have to take notes on. It's all things that I think are very important for this section in geometry. What you should assume and what you should not assume in geometry. Alright? So Swabi, can you read me the things that you should assume?
Straight lines and angles, collinear points, betweenness of points, relative positions of points.
Relative positions of points. So if you see a straight line or you see a straight angle, you can assume it to be such. Okay, you don't have to be told otherwise. It doesn't have to be stated in the problem. You can assume it. You can assume if points are on a line that they are collinear. They're on the same line. You can assume that a point might be between two other points. These are all things you can assume. And then just the relative position of points. If one is above another, if one is next to another, just general positioning of points. But Markina, what can we not assume?
Right angles, congruent segments, congruent angles, and relative sizes of segments and angles.
Good, you better believe that if you're going to assume anything in a diagram, if it's to be right, it has to be labeled, okay? Do not just think because it looks like it's 90, it is. It could be 91, it could be 92. It must be labeled, okay? Congruent segments, again, labeling with those dash marks. Congruent angles, again, with dash marks. And then just the size of a segment, don't assume it's double or triple or relative to another. It must be told to you. So things you should not assume, things you should assume. Alright, let's get into doing some proofs. Mr. Mo, do you want to take this part?
Nope.
Alright, a big part of geometry involves the challenge of proving things. One way in which to do this is using something called a two-column proof. These proofs involve using theorems. A theorem is a mathematical statement that can be proven, or that can be proved. We're going to do that right now. Now I will tell you this lesson today is just a baseline for what you're going to do in the next couple of weeks. This might seem kind of simple or obvious, but it's going to get harder as you grow through this. So make sure you know this is the just basis of what you're going to do later, next week, the week after. So here we go. Theorem 1 is going to be this. We're going to try and prove the theorem that if two angles are right angles, then they are congruent. This actually is the first theorem on those blue sheets that I gave you. We're going to prove it. Seems pretty obvious, right? If two angles are right angles, they have to be equal. But this is how we're going to walk through a statement and reason proof. So watch here. Number 1. Please number your statements in this column. We're going to state that angle A is a right angle. So if you look back at what was given to you and what you need to prove, we were given that angle A is a right angle, and we are also given that angle B is a right angle. Well, we need to prove they're equal. So this part right here, the reason you're stating it is because it was given to you. You will often put your givens right in your two-column proof. You use it as part of your rationale. So what are we going to then say from there? What do we know about right angles? They're 90 degrees. So can we assume then that the measure of angle